Chapter 15 in class exercise 3, problem number 15.64. Ball A has mass of 3 kg and is moving with velocity of 8 meters per second when it makes a direct collision with ball B, which has mass of 2 kg and is moving with velocity of 4 meters per second. If coefficient of restitution E is 0.7, determine the velocity of each ball just after the collision. Neglect the size of the balls, means consider them as particles. What we know here is VA1 and VB1. This is very similar to the problem involving collision of two cars, rail cars. However, what we do not know is neither the velocity of A or B after impact. So let's say then this is the impact, and then after impact, we do not know the velocity of ball A and ball B. So looking at the mass of ball A, which is 3 kg, and velocity of ball A, which is 8 meters per second, when ball B has lower mass and lower speed, there are great chances that after impact, ball A and B they together move in the right direction. So A and B after impact they both move in the right towards the right direction. So VB2 and VA2. This is our assumption. This may or may not be right, but it makes sense looking at that this ball is heavy, like 5 kg, and it's 3 kg, and it's moving at 8 meters per second, and this is lightweight, which is 2 kg, and moving at less speed. So after collision, ball A dominates ball B's speed, and they together move in the right direction. Our assumption is going right is positive for all velocities. Okay, so let's write down what parameters we have been given. So MA is 3 kg, MB is 2 kg, VA1 is 8 meters per second, VB1 is minus 4 meters per second, negative because it's going left and going right is positive. VA2 we don't know, but we will consider that as positive VA2 because it's going right. VB2, that's what we need to determine, is VB2 positive. So this is what we need to determine through our problem solving. So, and we have been given, yes, coefficient of restitution is given as 0.7. Okay, so let's apply the solution. So step number 1 is apply conservation of momentum, that is sigma MIVI1 is equal to sigma MIVI2. That means MAVA1 plus MBVB1 equals MAVA2 plus MBVB2. Now we can substitute known values here. So this is 3 times 8 plus 2 times minus 4 equals 3 times VA2 plus 2 times VB2. Now that's equation number 1. We cannot solve it because we do not know either VA2 or VB2. So we have two unknowns in one equation. However, we know coefficient of restitution, which is VB2. This formula will be given to you in the exam, minus VA2 divided by VA1 minus VB1. This is given as 0.7, and now VB2 is towards right, so it's positive. VA2 is also positive, but this VA1 is 8 and VB2 is minus 4. Now this negative sign here, that's actually part of the equation, and this negative here is because it's ball B is moving towards left. So when we rearrange this equation, we get VB2 minus VA2 equals 8.4. And that's second equation. So we have two equations and two unknown, and we can now solve this problem. So we can actually write VB2 in terms of VA2 and substitute that here, and then solve for VA2, and then later solve for VB2. Okay. So solving 1 and 2, we get VB2 equal to 8.24 meters per second, and VA2 we get as minus 0.16 meters per second. Now this is an interesting point to notice here, that we get the negative sign. What it means, that our assumption of A going right is not correct. A will bounce back little bit and B will go right. B will absolutely bounce back with much higher velocity, but A will also bounce back little bit towards left. So we get, so that means the final answer is VA2. We need to correct this, so we will write as 0.16 positive number, but change the direction of the speed. Okay, so and V2 goes towards right. So finally, after impact, A goes left with 0.16 meters per second, and B goes right with 8.20 meters per second. And that's the final solution. So let's look at the approach how we solve the problem. So because we do not know velocities of both the objects after impact, we cannot solve the problem using only conservation of momentum equation. We need another equation, that is coefficient of restitution. And using these two equations, we can solve for two unknowns. Thank you.